This is Anthony Precella working some algebra class with my favorite college algebra, or working some algebra problems, my favorite college algebra class. This is, today we're going to have a assignment that's sort of a hodgepodge of several things. It's assignment 11, and we're going to look at operations of functions, adding, subtracting, multiplying, dividing functions. That DQ stands for something called the difference quotient, which that's the next thing, and then something called composition of functions. So what I've done here is just printed out the homework, and I'm just going to be working some examples for y'all like this. And the first assignment, or the first problem, I might really be insulting y'all's intelligence by doing this one. But it says, okay, let f of x equal 7x plus 4. G of x is 2x minus 7. And it says find f plus g of x. Now that doesn't mean times. What this notation means here is f of x plus g of x. So you're trying to find f of x plus g of x. So how would you do that? Well, just write down f of x. F of x is the 7x plus 4. And then that purple plus. I don't know if y'all can tell the colors on there. And then g of x, 2x minus 7. Is that what y'all would have guessed this meant if you'd just been forced to guess on how to do this? F of x plus g of x, would you have just added f of x and g of x? So when we add those together, what do we get there? It's going to be our first answer here. Let's see, are y'all not talking? See, 7x plus 2x, that's a 9x. My brother tells me he has a class that won't say anything. And I was like, wow, this semester I've been pretty lucky. I haven't had that. So we have 9x, and is it a minus 3?
Still trying to get it,
Hmm? Oh, am I going too fast? Y'all caught up?
Okay.
So that f plus g of x just means write down f of x, write down g of x. Sometimes students think, oh, it means distribute the x or doing something really strange. No, it's just a short way of writing f of x minus g of x. Like the second one, the f minus g, it's going to be the same thing we did here in the previous one, except if there's a minus in front, what are we going to have to do? Let's see. We write down f of x, that's 7x plus 4, and I'll put that minus in purple. G of x is 2x minus 7. And what I've written right here, there's a little something wrong there, the way I have it written. With the minus in front, that means subtract all of that. So if I put the parentheses there, what am I trying to say we're going to have to do with this minus? Distribute it. So it would be 7x plus 4. Then when I distribute that purple minus, ooh, it's going to be and y'all can't tell it's a purple, can you? Oh, it is. Minus 2x and a plus 7. So what would that be? 5x plus 11? Yeah, so that's what I would type in this box here. Some of y'all actually do print out your homework, right? Or do y'all not know? If you click on the little print icon, you have the choice of either printing out one problem. I don't know why you want to print out just one problem, or the whole assignment. And if you print out the whole assignment, then you can just go through and work it on the paper, and then when you have a chance, punch in the answers. Okay. Now this third one. So we've added functions, we've subtracted functions. After adding and subtracting, what's the next thing you do in grade school? You multiply and divide. So okay. To multiply, that's f of x. This fg of x, that means f times g. F of x times g of x. Oh, I'm mixing my colors. Oh, well. So you just multiply those together. There's a four-letter word that starts with F. What am I hinting that for? Going to have to FOIL this out. So what would we have there? 14x squared minus 49x. Then what? Plus 8x and minus 28. So let's see. What? Combining the like terms, nothing I can add with the 14x squared. And let's see, negative 49 plus 8, is that a negative 41x? And a minus 28? Okay. So we've added, subtracted, multiplied, divided. Any questions? This is one of those problems that just won't end. It keeps going and going. But at least we're up to a pretty easy one. That f over g of x. What that means is write down f of x over g of x. Ooh, I'm out of room. You know what? There's not going to be much work to this one. I think I'll put it just right here. Here's what the answer is. You're just going to write down the answer. You write down f of x and then over g of x. So the f of x is 7x plus 4, and the g of x is 2x minus 7. Okay, that goes there. Any questions?
Is it always going to be like that, or are you going to have ones where you have to simplify the division?
Well, the one that you're going to have is just going to be like that. Okay? I guess theoretically, if you had some quadratics, quadratic over quadratic, and you could factor and cancel something, but I didn't see anything like that. Okay, in the homework. So just sort of giving you an idea of what the heck these operations mean. If you see a f plus g parentheses x, it doesn't mean at any point that you're multiplying by x or something. Sometimes that's what students think it means. It just means write down f of x and plus g of x. So this f over g with the x out there just means f of x over g of x. Now, we stated some rules, or we found some domains on, was it a week ago today? We had some rules when we first began functions. Yes. And we were told find the domain, and right here, find the domain of f plus g. Well, let's look at the domain of f and the domain of g. Do y'all remember the things you want to avoid when you're finding domains? You want to avoid getting a zero where on a fraction? On the bottom. You don't want a number over 0. Also, what sort of numbers do we want to avoid? We don't want under square roots. Negatives. Well, none of these have any square roots, but we better make sure we don't wind up with a 0 in the bottom of a fraction. But like for f and g, what are their domains? Remember we said negative infinity to infinity. There's no square roots and no fractions. What about f plus g? Are there any square roots or fractions? What about f plus g, f minus g, and f over g? Are there any square roots or fractions on these three? Now, so what am I trying to say you're going to write for the domain of f plus g, f minus g, and f times g?
Negative infinity.
Yeah, negative infinity to positive infinity. Ooh, can y'all tell that's a negative? It's all real numbers. Negative infinity to positive infinity. Negative infinity to positive infinity. Why are we saying that's the domain? Well, for those three, there are no square roots, no fractions. Why did I not immediately fill in the f over g domain as all real numbers? Well, yeah. the domain of f is all real numbers, the domain of g is all real numbers, but when we look at f over g, there's one number that we can't plug in for x, and it's not an integer, it's a fraction. Remember, how would I would say, okay, the denominator can't be what number? 0. So how would we go about that? Maybe move the 7 over, and then what? Divide by 2? So here's the one number you can't plug in for x. Every other number you can plug in for x. The only number you can't plug in for x is 7 over 2. And how do you write that in interval notation? There's sort of a little fancy way. How do we say every number except 7 over 2? Well, it would be negative infinity to 7 over 2, and then 7 over 2 to infinity. What would I put on the 7 over 2? Open or closed circle? Open. So here's the thing you would have to type in to get for this answer. It'd be parentheses, negative infinity, comma, 7 over 2, union, parentheses, 7 over 2, comma, infinity. Remember, that's sort of a fancy way of writing all real numbers except 7 over 2. Any questions? You're sort of working through the homework. If I get it all done, immediately under this homework assignment, I'll have a thing when you click on homework that says class, video of class lecture, today's class lecture. If you want to see it, I'm speaking to those people that aren't here right now. If they want to see what we've done, then that's what I'm ultimately hoping for. That's my ultimate goal. Okay, in case you're wondering, why is he doing something different? No, I didn't hurt my foot. Just thought it'd be good to try something different like this. So, problem number 2. That was by the way, problem 1 was the sum, the operations part. Add, subtract, multiply, divide. Okay, we're doing the operations. Okay, everyone's problem 1 will work out like that. Okay. Problem number 2 is the part that I called, it's sort of hard to read, isn't it? But I'm going to write it down. Problem number 2 says f of x is x squared plus 9. And this is going to an ABC part problem here. So problem A says to find f of x plus h. Well, again, this is something we did a week ago, where we were talking about, okay, with this function notation, whatever's in the parentheses, you plug it in for x. Whatever's in the parentheses, you plug in for x. So I'm going to put an x plus h in place of this purple x. You may not be able to tell that's a purple x, but it is. We have x plus h squared plus 9. This is going to be a 3-part problem, and the most involved part is the first part. F of x plus h. You plug x plus h in for the x. Now, what am I going to do with this x plus h squared? I don't just square the x and square the h. What do I do? Starts with f? Yeah. Some of you can foil this in your head. I'm just showing my thoughts here, foiling it out. Okay, it'd be x squared. The xh plus xh, that would be plus 2xh plus h squared. So foiling out the x plus h squared. It'd be x squared plus 2xh plus h squared, and then a plus 9. That's f of x plus h. There's nothing to simplify there, nothing I can combine. So there's the answer to the first part of the problem. It says find f of x plus h. So that answer would be x squared plus 2xh plus h squared plus 9. Now, part B says to find, it's going to look sort of strange. Part B says to find f of x plus h, then minus f of x. Ooh, let me see. Can I arrange this there? Well, this is one of those where you're going to use your answer to part A in order to do part B, and this is going to be the pretty fast part here. It's part A that takes a while. Part B and C should fall out pretty easily. What you're going to do is you're going to think of this minus the same way you did in grade school. Remember when you first saw subtraction, your teacher probably talked about take away. So what you're going to do is look at your answer from part A. Then take away everything. Now f of x was the original function. So look at your answer from part A. Take away everything in the original function. So looking up here, which ones am I taking away? The x squared and the 9. It's going to look like I'm just popping my answer out. What am I about to write the answer is? 2xh plus h squared. So right here, let me use 2xh plus h squared. That's my answer for right there. See, it's part A that can take a while, especially if you have some foiling to do and stuff. Now, part C, you're going to use your answer from part B. Let me go ahead and write a little something. This strange looking fraction, f of x plus h minus f of x all over h, any first semester calculus student worth of salt can tell you that's an integral part of the definition of derivative. It's called the difference quotient, and that's the DQ part of the assignment. Difference because of the subtraction, and then what do you call a division problem? The answer's the quotient. So it's called the difference quotient. Big part of any sort of first semester calculus course. All we're doing is just finding the difference quotient. We're not doing any calculus here. So look at the top part. Where did we get the answer to the top part? It's in part B. So you're going to write down part B and put it over 2xh plus h squared. Put each of those over h. Ooh. Let me see if I can make this brighter. I don't think I can. No matter what. Moving up a little more. So I took the answer from part B, put each term over h, and what are we going to get here? You can cancel these h's here, and you can cancel one h. One of the red h's, I can cancel with that h in the bottom. That's why I'm marking off that exponent. So what am I left with? Just a 2x plus h? So in this box,
I'm confused.
okay,
Well, it says f of x plus h minus f of x. Why did you put 2xh plus h?
the 2xh plus that's part B.
Oh, so you write it like that?
I took the answer from part B, the f of x plus h minus f of x. That's the second part
Oh,
we
okay,
did.
I get it.
Okay, so you take this answer and put it over h.
Okay. I realized the answer when I asked the question.
Oh, okay. Okay, so you're taking the answer from, this is a three-step process for finding the difference quotient. In the calculus course, and I think in the business calculus course my brother's teaching right now, he says my math lab keeps talking about the four-step process for using the difference quotient to find derivatives. And the fourth step that we're not doing here, because we're not finding derivatives, is to replace the remaining h with a 0. But that's not what we're doing here. Okay? So it's a three-step process. You plug the x plus h in. And you probably have to FOIL and simplify. Then, to do the minus, you take away everything that's in the original function from the f of x plus h. And then put everything over h and cancel. Are we ready to do another one like that? It's number 2. And we're going to do problem number 3, which it's sort of nice, okay, at walking you through those steps, but when you're having to type in the answers, maybe you would rather it just ask for the last answer, and that's what problem 3 does. You don't type in each one of these, the f of x plus h, the f of x, and the h. Okay, so flip into problem 3. I'll work it out right. This is problem number 3. All it says is find the difference, find f of x plus h minus f of x all over h. So we have f of x. Says, okay, this expression is called the difference quotient, so it's giving you the terminology right now. Find and simplify the difference quotient for the following function. So here's what we have. F of x equals 3x squared plus 6x plus 3. That's the original function. And I'm going to break this up into, well, sort of. I'm going to first find the f of x plus h part. I'm going to do that in red. Then in black, I'm going to take away the original function. I'm going to do the minus f of x part. And then the third part, I'm going to divide by h.